All right, I'm in the private oral exam guide. I'm going to be in chapter 3, determining performance and limitations. A is aerodynamics. What are the 4 dynamic forces that act on an airplane during all maneuvers? Lift, the upward acting force. Gravity or weight, the downward acting force. Thrust, the forward acting force. And drag, the backward acting force. What flight condition will result in the sum of the opposing forces being equal? In steady state, straight and level, unaccelerated flight, the sum of the opposing forces is equal to 0. There can be no unbalanced forces in steady straight flight. Newton's third law. This is true whether flying level or when climbing or descending. This simply means that the opposite forces are equal to and thereby cancel the effects of each other. What is an airfoil? State some example. An airfoil is a device which gets a useful reaction from air moving over its surface, namely lift. Wings, horizontal tail surfaces, vertical tail stabilizers, vertical tail surfaces, and propellers are examples of airfoils. What is the angle of incidence? The angle of incidence is the angle formed by the longitudinal axis of the airplane in the chord of the wing. It is measured by the angle at which the wing is attached to the fuselage. The angle of incidence is fixed and cannot be changed by the pilot. What is relative wind? Relative wind is the direction of the airflow with respect to the wing. When a wing is moving forward and downward, the relative wind moves backward and upward. The flight path and relative winds are always parallel but travel in opposite directions. What is the angle of attack? The angle of attack is the angle between the wing chord line and the direction of the relative wind. It can be changed by the pilot. What is Bernoulli's principle? Bernoulli's principle, the pressure of a fluid, liquid or glass, decreases at points where the speed of the fluid increases. The pressure of the fluid decreases at points where the speed of the fluid increases. In case of airflow, high-speed airflow is associated with the low pressure and low-speed flow with high pressure. The airfoil of an aircraft is designed to increase the velocity of the airflow above its surface, thereby decreasing the pressure above the airfoil. Simultaneously, the impact of the air on the lower surface of the airfoil increases the pressure below. This combination of pressure decrease above and increase below produces lift. What are several factors which will affect both lift and drag? Wing area. Lift and drag acting on a wing are roughly proportional to the wing area. The pilot can change wing area by using certain types of flaps, Fowler flaps. Shape of the airfoil. As the upper curvature of an airfoil is increased up to a certain point, the lift produced increases. Lowering an aileron or flap device can accomplish this. Also, ice or frost on a wing can disturb normal airflow, changing its camber and disrupting its lifting capability. Angle of attack. As angle of attack is increased, both lift and drag are increased up to a certain point. Velocity of air. An increase in the velocity of air passing over the wing increases lift and drag. The air density. Lift and drag vary directly with the density of the air. As air density increases, lift and drag increase. As the density decreases, lift and drag decrease. Air density is affected by the factors pressure, temperature, and humidity. What is torque effect? Number 9. Torque effect involves Newton's third law of physics. For every action, there is an equal and opposite reaction. Applied to the airplane, this means that as the internal engine parts and the propeller are revolving in one direction, an equal force is trying to rotate the airplane in the opposite direction. It is greatest when at low air speeds with higher power settings and a high angle of attack. What effect does torque reaction have on an airplane on the ground and in flight? In flight, torque reaction is acting around the longitudinal axis, tending to make the airplane roll. To compensate, some of the older airplanes are rigged in a manner to create more lift on the wing that is being forced downward. The more modern airplanes are designed with the engine offset to counteract this effect of torque. On the ground, during takeoff roll, an additional turning moment around the vertical axis is induced by torque reaction. As the left side of the airplane is being forced down by the torque reaction, more weight is being placed on the left main gear. This results in more ground friction or drag on the left tire than on the right, causing a further turning moment to the left. What is the 4 factors that contribute to torque effect? Torque reaction of the engine and propeller. For every action, there is an equal and opposite reaction. The rotation of the propeller from the cockpit to the right tends to roll or bank the airplane to the left. Gyroscopic effect of the propeller. Gyroscopic precession applies here. The resultant action or deflection of a spinning object when the force is applied to the outer rim of its rotational mass. If the axis of the propeller is tilted, the resulting force will be exerted 90 degrees ahead in the direction of rotation and in the same direction as applied force. It is most noticeable on takeoffs and tail draggers when the tail is raised. Corkscrew effect of the propeller slipstream. High-speed rotation of an airplane propeller results in a corkscrewing rotation to the slipstream as it moves rearward. At higher propeller speeds and low force speeds, as in takeoff, the slipstream strikes the vertical tail surface on the left side, pushing the tail to the right and yawing the airplane to the left. At high propeller speeds and low forward speeds, as in takeoff, the slipstream strikes the vertical tail surface on the left side, pushing the tail to the right and yawing the airplane to the left. Asymmetrical loading of the propeller, P factor. When an airplane is flying with a high angle of attack, the bite of the downward moving propeller is greater than the bite of the upward moving propeller. This is due to the downward moving blade meeting the oncoming relative wind at a greater angle of attack than the upward moving blade. Consequently, there is a greater thrust on the downward moving blade on the right side, and this force is primarily to yaw to the left. What is centrifugal force? Centrifugal force is the equal and opposite reaction of the airplane to change in direction, and it acts equal and opposite to the horizontal component of lift. What is load factor? Load factor is the ratio of the total load supported by the airplane's wing to the actual weight of the airplane and its contents. In other words, it is the actual load supported by the wings divided by the total weight of the airplane. It can also be expressed as a ratio of a given load to the pull of gravity, i.e., to refer to load factor of 3 as 3 Gs. In this case, the weight of the airplane is equal to 1 G, and if a load of 3 times the actual weight of the airplane were imposed upon the wing due to curved flight, the load factor would be equal to 3 Gs. For what two reasons is load factor important to pilots? Because of the obviously dangerous overload that is possible for a pilot to impose on the aircraft structure. Because an increased load factor increases the stalling speed and makes stalls possible at seemingly safe flight speed. Because the increased load factor increases the stalling speed and makes stalls possible at seemingly safe flight speeds. What situation may result in load factors reaching the maximum or being exceeded? Level turns. The load factor increases at a terrific rate after a bank has reached 45 or 50 degrees. The load factor in a 60-degree bank turn is 2 Gs. The load factor in an 80 bank turn is 5.76 Gs. The wing must produce lift equal to these load factors if altitude is to be maintained. Turbulence. Severe vertical gusts can cause a sudden increase in angle of attack, resulting in large loads which are resisted by the inertia of the airplane. Speed. The amount of excess load that can be imposed upon the wings depends on how fast the airplane is flying. At speeds below maneuvering speed, the airplane will stall before the load factor can become excessive. At speeds above the maneuvering speed, the limit load factor for which an airplane is stressed can be exceeded by abrupt or excessive application of the controls or by strong turbulence. What are the different operational categories for aircraft, and within which category does your aircraft fall? The maximum safe load factors, limit load factors specified for airplanes and the various categories are as follows. Normal category, 3.8 to negative 1.5 Gs. Utility, mild aerobatics, including spins, plus 4.4 to negative 1.76. Aerobatic, plus 6 to negative 3. What effect does an increase in load factor have on stalling speed? As the load factor increases, stalling speed increases. Any airplane can be stalled at any airspeed within the limits of its structure and the strength of the pilot. At a given airspeed, and load factor increases as angle of attack increases. As the wing stalls because the angle of attack has been increased to a certain angle, therefore there is a direct relationship between the load factor imposed upon the wing and its stalling characteristics. A rule for determining the speed at which the wing will stall is that the stalling speed increases in proportion to the square root of the load factor. Define the term maneuvering speed. Maneuvering speed is maximum speed at which abrupt control movements can be applied or at which the airplane could be flown in turbulence without exceeding design load factor limits. When operating below this speed, a damaging positive flight load should not be produced. When operating below this speed, a damaging positive flight load should not be produced because the airplane should stall before the load becomes excessive. Discuss the effects of maneuvering speed on an increase or decrease in weight. Maneuvering speed increases with an increase in weight and decreases with decrease in weight. An aircraft operating at a reduced weight is more vulnerable to rapid accelerations encountered during flight through turbulence or gusts. Design limit load factors could be exceeded if a reduction in maneuvering speed is not accomplished. An aircraft operating at or near gross weight is in turbulent air is much less likely to exceed desired limit load factors and may be operated at the published maneuvering speed for gross weight if necessary. What causes an airplane to stall? The direct cause of every stall is an excessive angle of attack. Each airplane has a particular angle of attack where the airflow separates from the upper surface of the wing and the stall occurs. This critical angle of attack varies from 16 to 20 degrees depending on the airplane's design, but each airplane has only one specific angle of attack where the stall occurs, regardless of airspeed, weight, load factors, or density altitude. What is a spin? A spin is a small airplane. A spin in a small airplane or glider is a controllable, recoverable, or uncontrollable, possibly unrecoverable maneuver in which the airplane or glider descends in a helical path while flying at an angle of attack greater than the critical angle of attack. Spins result from aggravated stalls in either a slip or a skid. If a stall does not occur, a spin cannot occur. What causes the spin? The primary cause of an inadvertent spin is exceeding the critical angle of attack while applying excessive or insufficient rudder and, to a lesser extent, aileron. When are spins most likely to occur? A spin stall situation can occur in any phase of flight, but is most likely to occur in the following situations. Engine failure on takeoff during climb-out. Pilot tries to stretch glide to landing area by increasing back pressure or makes an uncoordinated turn back to departure runway at a relatively low airspeed. Cross-control turn from base to final. Slipping or skidding turn. Pilot overshoots final, possibly due to crosswind, and makes uncoordinated turn at a low airspeed. Engine failure on approach to landing. Pilot tries to stretch glide to runway by increasing back pressure. Go around with full nose-up trim. Pilot applies power with full flaps and nose-up trim combined with uncoordinated use of rudder. Go around with improper flap retraction. Pilot applies power and retracts flap rapidly, resulting in a rapid sink rate followed by an instinctive increase in back pressure. What procedure should be used to recover from an inadvertent spin? Close the throttle if not already accomplished. Neutralize the ailerons. Apply full opposite rudder. Briskly move the elevator control forward to approximately the neutral position. Some aircraft require merely relaxation of back pressure. Others require full forward elevator pressure. Once the stall is broken, the spin will stop. Neutralize the rudder when the spinning stops. When the rudder is neutralized, gradually apply enough aft elevator pressure to return to level flight. What causes adverse yaw? When turning an airplane to the left, for example, the downward deflection aileron on the right produces more lift on the right wing. Since the downward deflection right aileron produces more lift, it also produces more drag, while the opposite left aileron has less lift and less drag. This added drag attempts to pull or veer the airplane's nose in the direction of the raised wing. Right, that is, it tries to turn the airplane in a direction opposite to the desired. This undesired veering is referred to adverse yaw. What is ground effect? Ground effect is a condition of improved performance the airplane experiences when it is operating near the ground. A change occurs in a three-dimensional flow pattern around the airplane because the airflow around the wing is restricted by the ground's surface. This reduces the wing's upwash, downwash, and wingtip vortices. In order for ground effect to be of significant magnitude, the wing must be quite close to the ground. What major problems can be caused by ground effect? During landing at the height of approximately 1/10 of a wingspan above the surface, drag may be 40% less than when the airplane is operating out of ground effect. Therefore, any excess speed during the landing phase may result in a significant float distance. In such cases, If care is not exercised by the pilot, he or she may run out of runway and options at the same time. During takeoff, due to reduced drag and ground effect, the aircraft may seem capable of takeoff well below the recommended speed. However, as the airplane rises out of ground effect with a deficiency of speed, the greater induced drag may result in very marginal climb performance, or the inability of the airplane to fly at all. In extreme conditions, such as high temperatures, high gross weight, and high density altitude, the airplane may become airborne initially with a deficiency of speed and then settle back to the runway. Alright, so we'll hold off there. That's section A for chapter 3, determining performance and limitation.